Let's take a look at how to solve quadratic equations by factoring. Remember, when you're solving a quadratic equation, you are looking for the x-intercepts, which are also known as the roots, which are also known as the zeros, and which are also called these solutions. They are one and the same. So the first thing we want to do is we want to set the equation equal to 0. So you can see I've got a 42 on the right hand side of the equal sign. I'm just going to subtract that from both sides, and that's going to leave me with x squared plus x minus 42 equals 0. Now I can easily factor this quadratic. I'm going to drop in my parentheses. I'm noticing already that I have a leading coefficient of 1. So the coefficient of the x squared term is just 1, which means I can just drop my x's in. I know if my c value is negative, my signs have to be different. One's going to be plus, one's going to be minus. And now I'm looking for two numbers that when I multiply them, I get a negative 42, but I add them, I get a positive 1. Well, I'm thinking right off the bat 7 and 6. And if you notice, 7 is bigger than 6, so that means 7 would have to take the sign of the middle term. And now let's double check that. 7 times negative 6 is negative 42, and 7 plus a negative 6 is a positive 1. So let's drop the 7 in with the plus and the 6 in with the minus, and I'm factored. To solve my equation now, I'm going to set each factor equal to 0 and solve. X plus 7 equals 0. Subtract 7 from both sides. X equals a negative 7. X minus 6 equals 0. We would add 6 to both sides. X equals 6. So if my x values are either negative 7 or positive 6, and you substitute them back into your original equation, you're going to get a 0, which means when your values of x are either negative 7 or 6, the corresponding y value will be 0, which means, of course, then it is on the x-axis. These are the x-intercepts. Let's take a look at B. Now, it might be tempting just to subtract 2x squared from both sides, but we don't ever want a negative in front of our leading coefficient. So what I'm going to do is I'm going to add 9x to both sides and subtract 5 from both sides. So that's going to leave me with 2x squared plus 9x minus 5. And as you can see too, when I use those properties of equality, essentially I just jump them over the equal sign and change their signs. Now I have a leading coefficient of 2. If I look, I can't factor out a GCF between any of these terms. I'm going to go ahead, we'll use the AC method, and I'm going to take 2 times negative 5. That gets me a negative 10. So I need factors of negative 10 that when I add them, I get a positive 9. I'm thinking 10 and 1. And the 10 would have to be positive. The 1 would have to be negative. So let's rewrite this 9x using these factors. And I get 2x squared plus 10x minus x minus 5 equals 0. And now 2x squared plus 10x plus negative x minus 5 equal to 0. Let's factor out a GCF. I can see 2x squared and 10x. Highest number I could divide them by is 2. So, and I can see I have an x squared here and an x, so it's going to be 2x. So that's going to leave me with x plus 5. And now here I'm going to factor out a negative 1. Okay, and now notice what's in your parentheses is the same. I'm going to factor out x plus 5. And what's left over is 2x minus 1 equals 0. And now we'll set each factor equal to 0 and solve. X plus 5 equals 0. Well, that means x equals negative 5. And when I look at 2x minus 1 equals 0, I'm going to add 1 to both sides. I get 2x equals 1. And then I would have to divide out that 2. So I get x equals 1/2. So my solutions, my x-intercepts, my zeros, my roots of this quadratic are x equals negative 5 and x equals 1/2.